Alrighty, so number 17 is asking us how many moles of chlorine ions are present in 18.4 grams of calcium chloride. So remember when PK talked to us about when we are talking about moles of something, then we are just talking about moles of that thing broken apart as well. So in 1 mole of calcium chloride, we have 1 mole of calcium and we have 2 moles of chloride. And in past videos I talked about, unless it's asking for atoms or molecules, we don't use Avogadro's number. So only when we were talking about atoms or molecules. So for example, in 1 molecule of calcium chloride, we have 1 atom of calcium and we have 2 atoms of chlorine. So if we're talking about molecules or atoms, then we would use Avogadro's number. But right here, it's only asking us for moles of chloride ions. So let's write that as our map. We have moles of chloride ions. We want something to do with moles, so we are not using Avogadro's number because atoms and molecules are not mentioned in the question. And we're not looking for any types of atoms or molecules. So we write what we're looking for and then we write what we're given, which is 18.4 grams of calcium chloride. Make this a little bigger so we have enough room. Okay, so the first thing that we need to do is figure out how much calcium chloride weighs, because in order to get rid of grams of calcium chloride, we need to use the molar mass. Remember, we want grams of calcium chloride down here. We're gonna want that per mole. So we know that chlorine weighs 35.45 grams per mole and calcium weighs 40.08 grams per mole. We know we have 2 chlorines, so we're gonna multiply. We're gonna do 35.45 times 2. And I'm just gonna do that on my computer. Okay, that equals 90 grams per mole. And then this is just, we only have 1 calcium. So now we're gonna add our 1 calcium plus our 2 chlorines. And that's going to equal 110.98 grams per mole. So for every 1 mole we have of calcium chloride, we are going to say it weighs, well, it doesn't, it does weigh 110.98 grams per 1 mole of calcium chloride. We want to make sure we write that every time. It gets tedious, but it helps us keep track of what we're doing. Okay. So we have 1 mole of calcium chloride on top, and we're looking for moles of chloride ions. So we're not ready to stop yet. How can we get rid of moles of calcium chloride and get chloride ions on top? Well, how many moles of chloride ions are in 1 mole of calcium chloride? There are 2 moles of chloride ions. Okay, so we can cross off moles of calcium chloride. Oops. And let's see, we have moles of chloride on top, and we need a moles of chloride on top, so we're gonna wanna stop here. Oops. Now we're gonna go over to our calculator. Maybe we are. Let's try that again. Okay. So we had 18.4 grams, and we want to make sure we do parentheses. That's the important part. We had 18.4 grams of calcium chloride on top, and we want to multiply that by 2 times 2. And now we're going to divide parentheses multiply our molar mass. We are going to get 0.33159. Okay, so we have 0.33159. And let's see, how many significant figures? We want 1, 2, 3. We have 1, 2, 3. We look at one more. We have 0.332 moles of chloride ions. And we do have that as an answer. Let's just say, for example, he wanted to know how many atoms of chloride ions there were. So we found the answer. I'm going to erase a little bit of this, but don't panic. Let's just pretend that it's asking how many atoms there were. And remember when I told you that if we're looking for atoms or molecules, we are for sure going to use Avogadro's number. I want to know how many atoms of chlorine there were. Ooh. So we know that there were 2 moles of chlorine in 1 mole of calcium chloride. And we're no longer looking for ions. We're just looking for atoms. How many chlorine atoms are in 1 mole of chlorine atoms? 1 mole of chlorine atoms, or chlorine. So in 1 mole of chlorine, there are Avogadro's number of atoms. Okay, let's do this in the calculator because this will be a good practice for us. So let's see, we have 18.4 times 2 times Avogadro's number. So we're going to do parentheses, 18.4 times 2. Now we're going to do Avogadro's number, so it's 6.022 second EE23. And parentheses, divided by the molar mass. And we get 1.9968. It's 10 to the 23 atoms of chlorine. And we need 3 sig figs, so it'd be, oh, okay, well that's just gonna mess with us. So we would have 2.00 times 10 to the 23 atoms. And remember, when you're looking for atoms or molecules, if that's the answer that you're looking for, it's gonna be a big number. But when we found moles, it was a small number. So that's another way you can tell, is you're going to get a small number if you're looking for moles, if moles are your answer. And you're going to get a big number if you're looking for atoms. So we were not looking for atoms, we just did that as a practice. And we'd already found our moles. But if you were looking for atoms, that's how you would go about that.